Hey everybody, Ms. Curdy here again for our final lesson on topic 6-6. And topic 6-6 is finding the area of irregular figures. So far we've only been looking at shapes that are squares and rectangles, but that's not realistic. Sometimes we'll have shapes that are not perfect squares or rectangles. So this is one of the more trickier topics, so you'll notice that there are 3 videos. You're only required to watch this first video and follow along with the note sheet. However, if you're not comfortable trying it on your own after that, there are 2 more videos, both with note sheets, that you can use to get some additional practice and follow along with me until you're ready to move on to the workbook and give this a shot on your own. So let's go ahead and get started on topic 6-6. Okay, so let's go ahead and get started. And now we're still going to be applying properties. And we already know that the distributive property tells us we can break a larger fact into 2 smaller ones and we'll still get the same product. And in this case, what we're going to be doing is we're going to be taking these shapes that are not perfect rectangles or squares, and we're actually going to break them up a little bit to figure out what the area is of those smaller shapes, and then we'll add them together to find the total. And again, we're going to be using the formula length times width equals area. So in this case, we've got 2 shapes that are not perfect rectangles. And what we're going to need to do is break them up to make smaller squares or rectangles. And it doesn't matter how you break them up as long as you are using the right length and width to find your areas. So in this case, I could break this down into a long skinny rectangle over here and another rectangle over here, or I can even chop this little guy right here and break it up into this small little shape here and this larger rectangle down below. After I have it broken up into squares and rectangles, I need to figure out what all of the side lengths are. Now down here is a little note that's saying you must have evidence when finding the side lengths. You can't just look at it and say, oh, well, it looks like it's 1 centimeter. But we can use what we know about squares and rectangles, knowing that opposite sides across from each other are always going to be equal. So I'm going to zoom into this one so we can get a closer look. Now looking at this, I know this top part right here is 1 centimeter. Now this side looks like it's 1 centimeter because it looks like it's the same, but I can't just base it off of that. I have to have some kind of evidence to know that it is 1 centimeter. So that's going to take some time, and I'm going to have to kind of look at it like a puzzle to figure out what all of my side lengths are. So I'm not sure what that piece is yet, but I'm going to kind of look around to see what I can do. So I know that this side right here is 7 centimeters, which is going to tell me that this whole side here, including that little piece I added, is also 7 centimeters. Now I'm looking over here, and I see that this side right here is 3 centimeters. And if I kind of follow that across, I know that this piece right here that matches up must also be 3 centimeters. So I think I'm getting closer to figuring out what this little missing side is. So I'm looking here, I've got this 4 centimeters, which tells me that this whole piece from here to here is 4 centimeters. And I know if this piece is 3 centimeters, this must indeed be 1 centimeter to make up for that total length of 4 centimeters, because 3 plus 1 equals 4. So now I know what all of the side lengths are. This side's also going to be 1 centimeter because it's across, and this little guy here is 1 centimeter because it's across. Now that I have all my side lengths, I can start finding the area of the 2 pieces. So this little square has a length of 1 and a width of 1. So that's going to give me 1 times 1, which is going to be 1 square centimeter. And down here, I've got 3 times 7, which is going to give me 21 square centimeters. Now, I want to be careful when I'm doing this that I don't use this 4 here and do 4 times 7, because that would be giving me this entire length and width, which is all this empty space up here. That's not what I want. This piece that I want is only 3 centimeters. And that's something that throughout this unit, we're going to have to be really careful with, that we're using just the pieces we need, nothing more, nothing less. And finally, to find my total, I'll take that 21 square centimeters and that 1 square centimeter and add them together to get my total area of 21 square centimeters. All right, now down here, I'm going to do the same thing where I can break my shape up. And it's actually the same basic shape, so I'm going to break it up a little bit differently to try something else. I'm going to break it up here. So I've got this long skinny rectangle, and then I have this other shape over here, this rectangle. Now at this time, if you want to pause the video and give this a try on your own, go for it. If not, you can follow along. But if you would like to, go ahead and pause the video now, solve it, and press play to check your work with me. Okay, so now looking at this, I know that I already have this piece right here. So it's going to be 1 centimeter times this giant piece. Now, all I know is that this little chunk here is 1 centimeter, but I don't know what the total is going to be because I don't know what this piece is yet. So I'm going to have to do some figuring, some work around here to figure out what that is. So I'm looking down here, I'm going to fill in stuff I already know. If this is 1 centimeter, I know that this little side over here is also 1 centimeter. And if this piece up here is 1 centimeter, then I know that this little piece down here is 1 centimeter. I also know that this entire piece down here is 8 centimeters. If this is 1 centimeter and the whole thing is 8 centimeters, I know that this little part is 7 centimeters, and 7 plus 1 gets me my total of 8. I know if this over here is 7 centimeters, then this piece up here must also be 7 centimeters, which makes sense because 7 plus 1 again gives us that whole side of 8. Let's look at the 6. If I know that this piece is 6 centimeters, then I know straight across matching up is also going to be 6 centimeters. Now I'm looking here, I still don't have this piece right here. But when I look across and I see that this is 6, this is 6, this piece must also be 6 centimeters. If this piece is 1 and this piece is 6, then this whole piece must be 7 centimeters. So now I have this piece here is 1, this whole piece is 7. So it'll be 1 times 7, and that 1 times 7 is going to give me 7 square centimeters. And now over here, I'm going to use this piece for my 7 right here and my 6 up here. So 6 times 7 equals 42 square centimeters. And finally, to figure out my total, I'm going to add 7 plus 42, and I'll get 49 square centimeters. So again, when we look back at this, there was a lot of work we needed to do ahead of time to be able to get to the point where we can use the formula length times width equals area. I first broke up my figure, and then I went through figuring out what pieces match up with each other. And remember, we can never say, well, it looks like it's 1 centimeter, or it looks like it's equal to this piece. We always must be looking for opposite sides. And opposite sides are across from each other. They're never attached at a corner. So I can't use this to help me figure out this side. We can only look straight across and straight up and down, never on that diagonal. That will never work for us. So if you're feeling confident, you can go ahead and try some of the practice problems in the workbook and use the answer keys to check your answer. Or you can meet me back here for the topic 6-6 more practice half sheet. And it looks like this. So if you would like to try that, you can look at the next video, and I'll see you back here in a moment. Have a great day.